Welcome everyone. Today we're going to talk about that nasty old tangent function. Okay, we know from way back in the day, last week and before, last year even, that sine theta behaves beautifully. Okay? And Megan, sine theta has a range of what values? -1 to 1. No problem. So we know you can pick a value and you can say, I don't know, let's say 30 degrees or pi over 6. We talked about that one just a little bit ago. If you go over here 30 degrees for theta, then f of theta for sine will be how much? How high will it go, Esme? Not yet. If you're not sure, look at your unit circle and go sine of 30 degrees. One half. There you go. So this goes up 1/2, Kobe. And so the same thing is, and we can say sine of 30 degrees, or pi over 6 if you're in radian mode, equals 1/2. And if you want to go the other way, you can say arc sine of 30 degrees, or I'm sorry, not of 30. Oop, don't ever do that. Arc sine of 1/2 equals, what will you get out of that, Zoe? Okay, if I go 30, I start here, I go up, boom, I run into the sine graph, and then, Zoe, I go over, and I hit 1/2. If I start here at 1/2, I go over, boom, I run into the sine graph, I go straight down, and I hit 30. There you go. Okay? A very important concept. So we said the range of the domain obviously is everything, all real numbers. The range is from -1 to 1. -1 to 1. So as we found out last week, if you try to do the arc sine of 3, what happens? If you try to do the arc sine of 3, what happens? It blows up. It says it's a domain error, which is actually a range error, but the calculator doesn't have that big a vocabulary because you're trying to take the arc sine of some value that's up here. You can't hit it, you know. It doesn't work. Tangent, however, is a totally different animal, and that's why it's a little bit harder to deal with. Take the tangent of 89.999 degrees. What do you get? Arlene, what do you get when you take the tangent of 89.999 degrees? Well, what units are we in here? Degrees, so we need to be in degree mode. Okay? $57.29 what? That's close enough. So yeah, it was funny. And Arlene, every year some students do that. They go, no, I did something wrong. That can't possibly be right. It looked very wrong. And then Rebecca bailed you out. Thank you. Thanks for the assist. It looks very wrong because we're used to things being, more nice. We're used to that being between -1 and 1 with good old sine and good old cosine. Tangent's a very different animal. So, Kobe, here's the deal. If we have our graph and we get out here near pi over 2, okay? or 90 degrees or pi over 2. I guess I should put that over on the other side. 90 degrees or pi over 2. And we start out here at 0. And you just saw, holy smokes, we need 60K. We need 30K. We need 15,000 and 45,000. And if you do this, and you have your theta here, this thing is going to go like this. It's going to start out really, really low. And then right at the end, it's really going to pick up steam. And it's going to do this. Okay? What happens if I go 59.9999? You can use your calculator or not. You can just tell me if you can see it in your head. What does it give you? I don't think so. Is it times e to the something? If you go tangent of 89.9999, it's not going to be 1. It's going to be big. Throw a bunch more 9s if you want. It's going to be gigante. It's going to be lunker. Yeah. It gets bigger and bigger and bigger. It gets into the millions. So what is happening there, David? What is happening at pi over 2? Yeah, I'm talking to the other David. How big? Infinitely big. Right, good answer. This thing keeps on going and keeps on getting closer and closer and closer as you get closer to 90. Gets closer and closer and closer. What's that called? No. What's it called? Starts with a V. Very close. It's called a vertical asymptote, and we've dealt with these before. And it gets closer and closer and closer, and this is a really important concept, everyone. So please understand. And let's talk briefly about why that's happening. Because what's the sine of 89.999? And what's somebody else do? Someone else, this side of the room. Kyle, your side of the room, do the cosine of 89.999. Which one? Okay, so this is almost 1. And what about the cosine? Can't be. Can't be. Sorry. Come on. Cosine 89.99. All right, what mode are you in? It's not right. Somebody else, please. Sarah? Thank you, Sarah. Good. It's not 1 point. I don't know what's going on. Okay. Guys, girls, this is really important. Okay, 1.7 times, and your calculator will lie to you. It'll say 1.7 e negative 5. Okay, what does this really mean? This is scientific notation, and that's one thing. I love those calculators, but those TIs, they've got to fix that. It's just so dumb. Scientific notation. This is not a negative number. It's a positive number. But what it means is go left. You've heard of go west, young man? This is go left. Okay? So it is 0.0000017. Okay? That's what that means. It means start here and go left 5 places. 1, 2, 3, 4, 5. How many zeros is that? 4. Okay? We started here and we went left 5 places because it's -5. That means left 5. Never, ever, ever write this on your paper, this e to the -5. That's going to, your college professors will go, man, your high school teacher was an idiot. Please don't ever write that on your paper. What it really means is 1.7 times 10 to the -5, really, or 0.00017, okay? Major. Kyle, is that okay? Okay, good. Good. That's a major one, folks. So that's a tiny little number, and I'm almost done. I'll shut up. Here we go. So you have almost 1 divided by 0.0000, almost 0. If you take almost 1 and divide it by a really, really little number, what happens? This is going to equal gigante. Okay? A really big number. In other words, that's why we get an asymptote, because you're dividing almost 1 by something really little. Really super little, Benjamin, and that gets you something super big. Even though you think, oh, 1, that's kind of wimpy, that's not that big. If you divide it into by a tiny, tiny, tiny number, you get a whole bunch of pieces. Okay? Questions? That's where it's coming from. And tangent is tougher to get. And then it gets even worse. It doesn't stop ever. That's the big thing. It goes up here infinitely high. Okay, that's why I put the arrow on. Then you try to divide by 0 at pi over 2, and it blows up. Then this is where it gets really cool. What does it do on this side, David? What does it do over here? How? You're right, but how? Well, think about it. You're going to be into quadrant 2 on your unit circle. You're going to be into quadrant 2 in your unit circle. So we have this and this. Again, we have almost 1 for our sine, our vertical component. What about our horizontal component, Esme? What's this going to be like? I don't need a number, just a description is fine. How kind of small? Positive small? Negative. So it's going to be way over here, a negative number close to 0. Okay? So it's going to be tangent of, 90.001 degrees. In other words, we're just on the other side of pi over 2. It's going to equal sine of 90.001 over cosine of 90.001. And as Esme said, that's going to be almost 1 divided by negative 0.00001 or whatever, ish. And then what kind of a number will that give me? Well, what we would think of as a huge number, but positive or negative. Negative, which is actually a really small number. And that's hard to get your head around, I know. So then, down here on this side, it's going to go like this, come up, and go like this. And David's right. It's going to repeat itself. Okay? And it's going to keep repeating itself. And that's why tangent is a really hard function to remember. Let's pull up the calculator briefly and look at that. Here is tangent. Here's tangent. Here's that pi over 2 we just dealt with. Notice it doesn't show the vertical asymptote. Starts again. When's the next asymptote on tangent? So pi over 2, and then when's the next one? Think about your unit circle, places where cosine are almost 0. Kobe? Close, but no. Where is it going to have another time when cosine is almost 0? Rusty? It would not be pi. Cosine at pi is -1, almost, around that region. It's -1 or a little bit less or a little bit more. We're looking where it's almost 0. Cosine is almost 0. Lost my calculator. Where are the two places on your unit circle where cosine is close to 0? Rusty? 3 pi over 2. So we are an asymptote at pi over 2, at 3 pi over 2, at negative pi over 2, negative 3 pi over 2, etc. And it goes on like that forever. Tough function, ladies and gentlemen. So I've been into this 16 minutes, and I think that's enough talking for today. And I'll let you work with some things.